Okay, the next topic deals with integrals of trig functions. In order to do that, we have to be aware of the 6 major trig functions: sine, cosine, tangent, cotangent, secant, cosecant, and how they are integrated. And these are the results here. Now, obviously, I'm not going to ask you to memorize them. And to be honest with you, I haven't really dealt with a true calculus class since 1970, when I proficiencyed out of a first full year of college calculus and went right into the 3rd semester calculus class, which about killed me and forced me to change my major from math to pre-med at the time. And I don't remember ever remembering having to memorize those, although I think in my high school class I did. We had to. But in the college class, by the time I got to 3rd semester calculus, we were dealing with stuff that was just so beyond the pale that my head was spinning constantly taking that class. So I'm not a good person to ask what happened back when. However, I'm not asking you to memorize it now, but do not be surprised if your professor in college will ask you to memorize these things. So it may not be a bad idea to start, looking at some things in the past that we've had and start remembering them then or now before you have to be forced to get into a pressure cooker of college calculus and memorize it at that point. Just saying. Anyway, these are the 6. Now I have a couple of proofs for this. I think I have the one for tangent, and I believe it's the one for secant. So let's take a look at the tangent x dx first. Tangent is also the sine over the cosine of x. And so that means that we're going to make u the cosine of x, the denominator, so that we can use the chain rule and the natural log proof there. The du, the derivative of u, then is going to be the negative sine of x. And so negative u prime will be the positive sine of x. And so we're going to plug that in for u prime over u, only it's going to be negative u prime because of the fact that sine of x is equal to negative u, and that's what that is up there. Sine of x should have dx there. Sine of x dx, and the derivative of that is over the cosine is equal to u, and we plug that in, and then u we know then is cosine of x. And so that shows you that the derivative of the tangent of x is the negative natural log of the cosine of x plus c. So that will show you where they got that from, where it came from. Do the same thing with the secant of x. Now, this is a little imaginative. In finding the integration of the secant of x dx, what they kind of knew ahead of time about how we can use functions of other trig functions, and that's what's going on here. Secant of x dx is multiplied by a value of 1, and any fraction divided by itself is 1. So they multiplied secant x plus tangent x over secant x plus tangent x because they knew the result of secant x times this is this value right here. Now, if you take a look at secant x plus tangent of x as your u, and you derive secant of x, and again, this is not something we memorize, so we have to go to your identities for these functions, for derivatives and all that. But the derivative of secant of x is secant x tangent x, and the derivative of tangent of x is secant squared x. And that's what we have up here. So that is our u prime. So it's a very clever manipulation of trigonometric terms there. So that means that our u prime is this value here, and our u is right there. And that, by definition of the integration of that, is the natural log of u plus c. And we said u is equal to secant x plus tangent of x. So that means then that the derivative of the secant of x is proven to be the natural log of the absolute value of secant x plus tangent x plus c. Now, you don't have to memorize those. We're just showing you that these are just not just some goofy ideas that a bunch of bizarre and out-of-the-world mathematicians came up with this stuff. There is basic proof, and while this is kind of a difficult jump, it makes sense once you see it done. And so hopefully that triggers you to look for those kinds of manipulations to solve problems in the future. We're not going to do that. And actually, I was just showing you where they came from. What we are going to do is something like this. Now for this one right here, we're asked to find the integration from 0 to pi over 4 for 1 plus tangent squared x dx, the square root of that. And so, that means then that we're going to have secant squared x is equal to 1 plus tangent squared x. And where do we get that from? That is also a trigonometric identity that's related to sine squared x plus cosine squared x equals 1. It's a derivation of that when we went through and divided everything, sine squared, cosine squared, divided everything by cosine squared x, and that gave us that right there. And anyway, so now we have the derivative of secant squared x, replacing 1 plus sine squared x, and that's going to equal the natural log of secant x plus tangent x plus c. And that means then that this is going to be equal to the natural log of those two from 0 to pi over 4. So we plug in pi over 4 and 0, pi over 4 for these two terms here, and for 0 for these two terms here. And when the smoke clears, we get this mathematical equation. And the natural log of 1, by the way, is not 0, so don't get cocky on that. Just type it in just like that, and you will get 0.881. Okay? Next problem. We're trying to find an average value of the tangent of x on the range from 0 to pi over 4 included. So when we're finding an average value, then that means we're using that delta x that we dealt with way back when, which we define as 1 over b minus a. So b is pi over 4 and a is 0. So that gives us 1 over pi over 4, and that's an inverted fraction, so we flip that back over there, and we get 4 over pi. So 4 over pi, our average, times the derivative of the tangent of x will give us our average value like we've done before. And we also know that the integration of the tangent of x is the natural log of the cosine of x going from 0 to pi over 4. So we plug in pi over 4 for the first time, and 0 cosine x, which is 0, which is natural log of, which is 1. So pi over 4 is 45 degrees, and the cosine of 45 degrees is pi over 2, so that's where that came from. And we're taking, and since this is negative over here, we pulled that on the outside, subtracted these two, multiplied by negative pi over 4, and we get 0.441. So, your practice problems are 30 through 36 on page 338. Have fun.